Hey guys, someone sent me a question concerning implicit differentiation, and this is a problem that I pulled from my math lab, and I thought I would work this out for you guys and share it with the class. If you view this this question, and you still have concerns or you still don't quite understand the problem or what I did, feel free to send me an email. I will be happy to help you. These problems are very long, but my advice is to remember all of your algebra rules, factoring, simplifying, um, remember how to combine common terms, all of that stuff, and take your time. Okay, make sure that you are not making any small mistakes in each one of your steps as you work. So let's jump into this. I may have to make 2 videos. I use a free app for these recordings. So if this happens to go over and I don't quite finish the video, you may have to watch a second one, but I hope not. So this was a problem from my math lab. And I want to make sure that you guys understand exactly what this is saying right here. This right here is asking us to find, let me make my marker a bit smaller, the second derivative of y with respect to x. That's how we would read that, the second derivative of y with respect to x. So what we're going to do is we are first going to take the derivative of this original equation, and we're going to find the derivative with respect to x. I'm going to just put it on the outside. Um, so here's the difference with the when we do implicit differentiation. Um, we know that if we were to take the derivative, and you don't have to write this down, if we were to have something like the derivative of 3x squared, that's going to be 6x. Okay. But now we don't just have x's in this equation. We have x's and y's. So when we take that derivative of that y, it's going to be a bit different. It's still going to be 2y, but we have to remember that we are taking the derivative of y with respect to x. So we have to notate that, and we have to actually put that in that equation there, that we took the derivative of y with respect to x. So that's the first part. In this middle part here, we have a y again. So we have to remember we have our product rule here. We have to apply that. But while we are applying that product rule, we have to find the derivative of y with respect to x. I'm going to put my minus sign, but because I'm doing my product rule, I'm going to put my bracket. So it's going to be that first term x times the derivative of that second term, which is going to be 1 dy over dx. So I'm just going to put dy over dx. That's the first term times the derivative of the second term plus the second term times the derivative of the first. So that, well, I didn't take the derivative of y, but now I'm taking the derivative of the x. The derivative of x is 1, so I don't really have to put it there. So I'm going to close my bracket. Plus, and then the derivative of this last term, x squared, is going to be 2x equal to 0. So you can pause this video. Do not forget that. This part here is the derivative of y squared. I got this middle part here. I'm taking the derivative of this middle part there. And then this last part here is the derivative of 2x. Okay, so now this is a bit different. What we now have to do is we have to solve this equation. We want to isolate that dy over dx. So we're solving an equation here. But before I do that, what I want to do is get rid of these brackets. I want to manipulate, simplify, and get rid of those brackets there. I'm going to drop down that 2y dy over dx. That's going to be minus x, and I'm just going to rewrite it as dy over dx. And then remember to distribute that negative through. Minus y plus 2x is equal to 0. Now, what I did here is I took these terms that do not have a dy over, and I took them across the equal sign. So when you do that, remember our signs will change. It will now be a y minus 2x on the right-hand side of my equation. Or yeah, of my equation. On the left side of my equation, I don't want to do too many steps here, but I would just leave that those terms there to have that dy over dx. And then I'm going to look at this like it's a common factor. And what I want to do is I want to factor out those common terms. So I'm going to bring out front my dy over dx, and I'm going to factor it out. In this first term, it's going to leave me with 2y. The second term is going to leave me with that minus x, and that's going to be equal to y minus 2x. Remember, you can pause this video. That's a great thing about videos. You can pause it, take a look at what I'm doing, think about it, and return to the problem. So I'm almost finished. Now I am trying to find, remember what we are asked to find here. The notation that we used actually asked us to find the derivative of y with respect to x. We're finding the second derivative, right? So to be able to find the second derivative, what we want to do is we want to isolate the first dy over dx. We want to isolate the that term there. So we're going to divide both sides. Oops. By that 2y minus x. And that's going to tell me that the derivative of y with respect to x, my first derivative, is equal to y minus 2x all over 2y minus x. I hope that was right. I hope I didn't mix my y's and x's up. Yeah, sometimes I have trouble reading my own handwriting. So circle this, guys. This is your first derivative. Now we will need that when we go to find our second derivative. Now I want to find my second derivative. So how are we going to do that? Well, I'm going to take that y minus 2x. Let's just rewrite the whole thing again so I can make a point here. So what we want to do is we want to take the derivative of each side with respect to x. And the reason I want to rewrite this way is so that you can actually see on the left-hand side, we have 2d's. That's the second derivative of y with respect to x. So you can kind of see where that notation comes from. It makes a little bit of sense. Now on the right-hand side, we have a quotient there. So we have to use our quotient rule. And guys, this is where you really have to pay attention to your algebra rules and take your time and write neatly. Most times that's where my students have trouble. It's just little small mistakes, nothing major. So let's take our time. Our quotient rule, the way I say it, I know it's not technically how the theorem reads, but I say that we take the bottom, which is that 2y minus x. It's the bottom times the derivative of the top. So that top is y, well, the derivative of y is 1. And you have to remember that anytime we take the derivative of y, we have to put dy over dx. So I'm not going to put the 1 there, but I will put dy over dx. So that's going to be dy over dx minus 2. So that's the bottom times the derivative of the top minus the top term times the derivative of that bottom term, which is going to be, it would just be 2, but because that y is there, we need to put dy over dx minus 1 all over that denominator squared. Now, from this point, what I did, because I did work this out before I shared it, just to make sure I didn't make any mistakes, what I did is I applied my distributive property. So let's pick a different color here for these first terms here. I have 2y times dy over dx, and the way I wrote dy, and then I have 2y negative 2, which gives me a negative 4y. And then I have, let's just change colors so you can follow it better. Negative x times dy over dx gives me negative x dy over dx. And then I have negative x times a negative 2, which gives you a positive 2x. Close parentheses. That's going to be minus, give me a minute, my computer's freezing up on me. Minus, it does not change color. Okay, so I guess it's not going to change color again. Then I have y times 2 dy over dx. That's going to give you 2y over dx. Then I'm going to have my y times negative 1, which gives me negative y. Then I have my negative 2x times 2, which gives me negative 4x dy over dx. And then plus 2. All over, this is what a lot of students forget. You have a complicated or complex numerator, we forget that denominator. And from here, guys, what I noticed is I had some like terms I could simplify. Let's see if it'll let me change the color. Nope. I have a 2y dy over dx and a 2y dy over dx. That simplifies. And then I have, oops, I forgot my x here. Go back and add that x at the end. And the reason I knew that x was there and I left it off is because I had a 2x here and I knew I had a 2x there. And because I'm subtracting, I should be specific and tell you why. Because I have a minus there and those are the same terms, I'm able to simplify or reduce, just cross those out because they're going to cancel one another out. And what that leaves me with is I have a negative 4y minus y minus a negative y. So that's a negative 4y plus y, which gives me a negative 3y. And then I have a negative x dy over dx minus a negative 4x dy over dx. That's the same as a negative x plus 4x, which gives me a positive 3x dy over dx. And then the denominator is going to stay the same. And I am going to stop this video because I know I'm running out of time. I will stop right here. So this will be the end of video 1. Okay. And I will resume video 2 shortly.